I'm just moving that out of the way, a little further away. All right, so this is section 2.2, and in section 2.2 we're looking at other types of graphs, and one of the graphs that we're going to look at is called a histogram, and so I'm going to teach you how to construct a histogram, both on paper and pencil, with paper and pencil, and with a calculator. Okay, so look, I've got the set of data. It's the height of a girls basketball team. Okay, and that's all raw data, right? It's just the numbers, and I want to be able to compile this into a histogram. And so I have to figure out what my histogram is going to look like, and as the statistician, a lot of that is my call. Okay? And one of the first things I have to do is decide how many bars I want to put in my histogram. Typically, the rule of thumb is anywhere between 5 and 15 bars. Okay? I decide. So the first thing I'm going to do as a statistician is I look at my data, and it goes from 62 to 72. And so my minimum is going to be at 62. I'm happy with that. But my maximum, I'm going to increase it a little bit. Okay? Now, I like even numbers, and so I'm going to choose 6 to be the number of bars. And so if I'm doing 6, that means, let's say I need to find a range of my data. Okay? If it's 72 and 62, what's the range? 10, right? Is 10 divisible by 6? No. 10 is not divisible by 6. Instead, I'm going to move up to 74. Because 12 is divisible by 2, or 6, I mean. You with me? That's how many bars I chose to have, right? If Emily would have said, I want 14 or 7 bars, then she would have went up to 14, so that it's even, right? Does that make sense? Okay, so now my bandwidth, and I'll explain what all this means as we go, is going to be 12 divided by 6, which is 2. Okay? So my bin width, which is the width of each of my bars, Hunter, is going to be 2. Yes, ma'am?
I was just wondering, so it's like on that scale, you would keep the lowest number the same?
Yes.
Always? It's the highest number that you would change?
Most of the time, yes.
Okay.
Yes. So then when I set up my histogram, I'm going to go here and here. If my low number is 62,
Mr. Hibb?
yes,
Can't see it.
my B. That means my bad. If my low number is 62 and I'm increasing my bin width is 2 units, then my next one's going to be at what?
64.
You guys are so smart. And then,
66.
and then,
72.
oh no, then 70, then 72. And then what was my maximum that I wanted to go to?
74.
74. Now here's the thing to remember. So within this interval between 62 and 64, I'm going to have all numbers that are from 62 up until 64, not including 64. Does 64 go on this side or this side? Yeah, the bigger side, right? Okay. So then I do my frequency. And so I'm going to go here, I'm going to go 1, 2, 3, 4, 5. I don't know how many I need to go, but I'm going to go at least 5. And then I start counting. And so how about from 62 to 64, not including 64, how many do I have? 1. So I draw my first bar of my histogram at 1. Yay. And then from 64 to 66, not including 66.
2.
Whoops. 2, and my bars are touching, right? And then from 66 to 68.
3.
3. And then from 68 to 70. 3 again.
Wow.
And then from 70 to 72. Oh, man. And then from 72 to 74. 1. Look how pretty that distribution is. Right? It's almost as if I planned it that way. Yeah. Okay, now, here's the thing. When I draw a distribution, you listening to me? When I draw a distribution, the one thing that we want to be able to do is we want to cuss it, right? Talk about the center, talk about the any unusual, any the spread of the data and the shape of the data. And we're going to learn terminology as we go along about those things. Okay, the centers. There's two different measurements of center, the mean and the median. Okay, the spread, we talk about the interquartile range and the standard deviation or variance. Okay. The shape of the distribution, either it's going to be symmetric, and we talked about that a little bit, right? Or it's on the vocab. Symmetric distribution means that it's even on both sides. This would be symmetric and bell-shaped. Okay. Skewed distribution would be where the tail is long on one side of the distribution. We'll talk about that as we go along. But that's what a histogram looks like. Okay, any questions on that? A lot of this I make up on my own. Not make up, but I figure out, right? How many bars I want. So that means this. If I want 6 bars and Jack wants 8 bars, does that mean mine's better than his? No. It just means it's different. Okay? It might look a little different. Look, if I do it in my calculator, and I've already oh, there it is. Whoop, there it is. So look, if I put my data in my calculator, right? So I put all my data in, then I go like this. I go second y equals. Why? Because that's called the stat plot. And what class is this? Statistics. You see where above there it says stat plot? And what color is it? Blue. So I hit the blue button and then y equals, and I get my stat plots. And what that does is it opens up this menu, and if it's not a food menu, sorry. If I go to plot 1, I can turn on plot 1, and I can choose different types of graphs. Okay, this is a histogram. Then remember our statistical zoom, right? If we go zoom 9, that's a stat zoom. Yeah, so look at zoom. If I hit zoom, what does it say there on 9? Zoom what? Stat. And what class is this?
English math.
Statistics, so I can zoom 9. But if I want to make this graph, and it does look like it, but it's not the same, look like this graph, then I have to change the bin width. So listen, here's how I change the bin width. If I go to window, my scale, oh, it already is. My scale is my bin width, and I want it to be 2. And that's why it looks the same. And if I hit trace, I can see that that bin goes from 62 to 64, but not including 64, right? And then this one goes from 64 to 66, but not including 66, and so forth. And it tells me the frequency. Cool? That's a histogram. Histograms are going to be our BFFs. That means best friends forever, okay, as we go along. There will be a lot of histogram drawing in this class, okay? All right. The next type of graph that we're going to look at is called a frequency polygon. Okay, a frequency polygon. So the way we do that, it's very simple. So what I did was I used the same data, but I broke it up into the bins, right? And so 1, 2, 3, 3, 2, 1, and that was my frequency. You with me here, Asante? And these are my bins, right, from 62 to 64, and then from 64 to 66. So I just made a table for my histogram. You with me? This is called a frequency table. Oh, we've done those before, Mr. Ever. Yes, we did. Remember, we then changed it to a relative frequency and then a cumulative relative frequency. Anywho, that's all free information. So what do I do with that? I can draw my frequency polygon, which looks very similar to our line plot that we did the other day. Okay? And so I go from 62 to 64 to 66 and so forth. And so I start at 2, 3. And so I go 1 up to 2, then 3, then 3, then 2, then 1, right? And so here's my frequency polygon. It looks like this. Okay? Looks like I just drew lines over my histogram, right? Pretty much what it is. Okay? It's just a different way to look at it. You with me? Now there's this thing called an overlay frequency polygon. And all that is if I want to compare that, let's say this is Montgomery Central's girls basketball team, right? And then we want to go up against, Kenwood's girls basketball team. And so they may have, 3 people that are this height and 4 that are this height and 2 that are this height and 2 that are this height. And then they have this, then they have one that's up here at 74 inches. Okay? She's a giant. So then what I would do is I would use a different color to represent the other one, and I'm overlaying it on top of the other frequency. And so I would have 3 at 66, and then 4 at 68, and then 2 at 70, and 1 at 72, and then 1 at 75. So it would look like this. Okay, and then you could compare, and we would know that the Kenwood girls are taller than the Montgomery Central basketball team. Cool, that's called an overlay, and you're just doing 2 time plots on the, frequency polygons on the same graph. Got it? All right. The last thing we're going to look at is what we call a time series plot, or a time series graph. And again, it's very similar to a line graph, very similar to a frequency polygon, but my x coordinates are all going to be times, right? And so when I do my x-axis, I start at 2010, and let's say this is somebody's growth from 2010 to 2019. So there's 11, 2012, 2013, 14, 15, 16, 17. I wish you guys would be quiet, please. 18, 19. And then my growth, and I might start at, I'm not going to start at 0 if my first value is not until 42. So I do this little thing right here, and it's called a graph break or a squishy thing, and what that means is that I'm scrunching up, bless you, I'm scrunching up the graph to show that there's a gap between there, right? And so I put 42 inches. And then in 2010, my subject was 42 inches, and then I increase, right, 42, 44, 46, 48, 50, 52, I'm not going to have enough room, 54, 56, 58, 60, and then 62, and I just add my points for each one. So in 2011 it was 44, and then 2012 was 45, which is halfway between 44 and 46, and so forth. You following me? And 13 was 48, 14 was 51, and 53, and so forth. And then my time series plot just records the time, the growth through time. You follow me? Okay, that's a time series plot. So those are the 3 main graphs that you need to be familiar with for section 2.2. Okay?
Wiggle mark has to be there.
Yes.